everyone! Welcome back to my YouTube channel. Again, I am Rica Casabuena from LaSalle Tasma Electronics Engineering, and for today's digital electronics vlog, we will be discussing about experiment number 3, the exclusive OR and the exclusive NOR gate. So just keep on watching and don't forget to subscribe and hit the like button. Enjoy! Now, before we start the experiment, we need to understand the objectives. For our first objective, we aim to realize the basic operations of a two-input exclusive OR and an exclusive NOR gate. And with that, we aim to realize the basic applications of the SOR gate when we connect it in the circuit. We will see it in the experiment. Now, as a reminder, the materials needed for the experiment will be discussed on each part of the experiment procedure. So just keep on watching and don't forget to enjoy while doing your circuits.
Now, let us understand what are the exclusive OR and the exclusive NOR gates. An exclusive OR gate is a digital logic gate that gives a true output when the number of true inputs is odd. Meanwhile, the exclusive NOR gate is a digital logic gate whose function is the logical complement of the exclusive OR gate. Now that you're ready, let's start.
Now, for our part 1, examining the basic operations of SOR gate, we will be needing a 7486 integrated circuit. Take note, as you connect the IC to the breadboard, take note of its notched for its polarity. As you can see from the diagram, the third pin of our 7486 is connected to a 360 ohm resistor. Okay? So, connect tayo ng 360 ohm resistor sa third pin. And to our resistor, there is an LED connected with it in series. And of course, for our LED to turn on, we will be grounding all of the components, okay? And of course, don't forget that our input A, or our white wire, is connected to the pin number 1 of the IC. And our input P, which will be our orange wire, will be connected to the first pin of our SOR gate. And now, let's not forget our VCC connection here, and of course, the grounding of our integrated circuit. That is really important. Do not forget it. And with all of those connections, this will be our part 1's circuit. Now, for our part 1 output, we will be having A input connected to ground and B input connected to ground as well. As you can see, the LED has been turned off. Now, if A is 0 and B is 1, okay, so the output will be 1, or the LED will be turned on. Now, if A is 1 and B is 0, so let's interchange them. So our output will be 1 as well. The LED is turned on. And lastly, if both inputs A and B is 1, the output will be 0, or the LED has been turned off. Now, for our part 2, examining the basic operations of XNOR gate, we will be needing a 74266 integrated circuit. Okay, let's connect it to our breadboard. As you can see from the diagram, the pin number 3 is connected to a resistor. So let's connect a connecting wire to our third pin, and from that, we will be connecting in series a 360 ohm resistor. Now, let's connect in series an LED, okay, to our resistor, and after that, let's ground our LED. Also, don't forget that we have our inputs A and B. Our input A, this will be our white wire, will be connected to the first pin of our integrated circuit, and our input B will be connected to the second pin of our integrated circuit, as you can see here in my connection. And after that, don't forget the grounding of our integrated circuit, because it is really essential that we ground all of our components. And don't forget the connection of the voltage supply to let the LED turn on. Now for part 2, XNOR, this will be our circuit connection. Now for our part 2 XNOR gate truth table, if both of the input is at 0, as you can see, umilaw yung ating LED. Our output will be 1. Now, if we take input A as 0 and input B as 1, as you can see, the output is 0. Now, if A is 1 and B is 0, the output will be 0 as well. Now, for the last inputs, if both A and B is connected to our VCC, our output will be 1. So you can see the LED has been turned on. So that's our truth table for part 2. For our part 3, single direction DC motor control, we will just be following the circuit diagram shown on the video to construct our circuit. We will be needing a 7486 integrated circuit, a relay, it should be 12 volts, a 1 kilo ohm resistor or maybe less than 1 kilo ohm resistor, a transistor, specifically a 2N3904 transistor, and a silicon diode. And of course, do not forget our motor because it will serve as our indicator for our outputs. And of course, let's not forget our VCC, which is 5 volts, and our VDD, our 12 volts voltage supply for our motor to spin as our output indicator. So just follow the circuit diagram to construct the circuit and just watch the video for the construction tutorial. For our outputs, for our single direction DC motor, if both input A, okay, this is the white wire, is connected to the ground or to zero, and input B is also connected to the ground or zero, as you can see, yung output natin is zero, meaning hindi umikot yung ating DC motor. Now, if A is 0, okay, and B is 1, as you can see, our output is 1. Meaning, yung ating motor ay umikot like an electric fan. Okay, it means that our output will be 1. Okay. Now, if we interchange the connection, if A is 1 and B, okay, is 0, as you can see, our output will also be 1, meaning that the C motor is on, or umikot yung ating LC. Like an electric fan, as you can see. Okay. And lastly, if both of the inputs are connected to our voltage supply, or if both of our inputs is 1, okay, input A is 1, and input B is 1, the orange wire, okay, if both of the white wire, or the input A, and the input B, or the orange Y, or the orange wire is connected to the voltage supply, our output will be 0, meaning hindi umikot yung LC na ating DC motor. And our output will be 0. So that's our output for our single direction DC motor. Now, for our last part, for the half adder circuit, we will be needing a 7486 integrated circuit and a 7408 integrated circuit as well. So let's connect it to our breadboard. As you can see on the circuit, the pin number 1 of the 7486 is connected to the pin number 1 of the 7408. And from this connection, we will be connecting our input P on the first pin of our 7408. This will be in series connection. Also, the pin number 2 of the 7486 is connected to the pin number 2 of our 7408 IC. And from this connection, we will be having our input A. It will be our white wire, which is connected to the second pin of our 7408 integrated circuit. Now, for our output, we will be connecting our first output on the third pin of our 7486. So here. And let's connect our resistor to that connection. And of course, don't forget our LED in series with our resistor. Now, for our second output, which is the letter C, we will be connecting the output to the third pin of our 7408. So, dito siya. And of course, again, don't forget our resistor to light up our LED later on. And of course, don't forget our second LED for our second output. It's better na iba yung kulay ng ating LED so that we will not be confused with our outputs later on. And now, let's have our proper grounding. Don't forget to ground both of your outputs, the output S and the output C, by grounding your LED. And of course, do not forget to ground your VCs, to ground your integrated circuit, both of them, the 7408 IC and the 7486 IC as well. And of course, don't forget our voltage supply connection for both of the integrated circuits. So, for our last part, the half adder, this will be our circuit construction. Now, for our truth table and for our outputs, let's turn on our voltage supply. If both input A and B is at 0 or it is connected to the ground, as you can see, our output for S is 0 and our output for C is 0 as well. Now, if we put the input A to ground and if we connected the input B to 1 here on the other side, as you can see, the output S is 1 or the LED for the output S is turned on. Meanwhile, the output C is 0 and the LED is turned off. Meanwhile, for our third combination, if A is connected to 1 and B is connected to 0, again, the S output is 1 and the C output or the green LED is 0. And last but not the least, if both input A is 1 and input B is 1, then the output C or the green LED turned on. It means that our output is 1 and the output S is 0, meaning the red LED is turned off. So that's our truth table for our half adder circuit. And that's the end of our experiment number 3. As our conclusion, in an XOR gate, the output is high if one and only one of the inputs is high. An XNOR gate is an XOR gate whose output is inverted. A half adder is a combinational logic circuit with 2 inputs and 2 outputs. Now, for our recommendations, please, to ensure that the circuit will be functioning, make sure that the connection is right. And don't forget the proper polarity of our integrated circuits or ICs. And also, don't forget the right connection of our relay to our voltage supply. Do not forget the 5 volts and the 12 volts supply because your motor will not spin if they are not connected. And of course, do not forget the right configuration of our transistor. The base, the emitter, and the collector should be connected appropriately. And with all of that, we already understand the basic operations of an exclusive NOR and an exclusive OR gate, as well as their applications. I hope you learned something from our episode today and see you on our next experiments. Bye and God bless you. Keep safe.